for joining on Zoom. Don't forget, we have a Facebook page. Go like it. I've been trying to keep things up to date. SBE election, just they finished up and announced all the people who won, and that is on our Facebook page as well. And then we're working on a newsletter. If you guys have any contributions that you want to do for each month, even if it's a one-time thing, send me an email, amandahoff@comcast.net. It's also on our main webpage. Next meeting will be next month, September 20th, right here again, as well as Zoom. I do believe, I didn't write it down. I think it's Link Up Communications, so they're local, so they should be in person as well. And then Kirk will probably plug this, but he has his own weekly YouTube program called This Week in Radio Tech. And I will make sure there's a link to this video, this meeting video, for everybody to go check it out. It's really fun. He does a great job with it. Anyways, that's about it. Kirk, I will let you take it. I will stop sharing my screen and you can do your thing.
Hey, wait a minute. And let me not share my screen just yet. And yeah, I can hear you okay, kind of, sort of, being the microphone that it is. How do I not share? Let's see. Never mind. I want to get a better view of everybody there. Oh, well. Okay, let me get this screen share done and share. So you should presently see Telos Alliance. Love what you hear. Everybody got that?
Yeah.
All right, cool. Well, Amanda, apparently you set the timer for about 2 hours. So I've got an hour and 53 minutes left. Gosh.
Let's not go that long.
Yeah, we're not going to do that. Not at all. Not at all. All right, let me get this. Hey, well, thanks for having me over. And Amanda, thanks for plugging my podcast. I've been doing that show for 14, maybe almost 15 years, something like that, maybe almost 14 years. Anyway, it's been 656 episodes. The episode that's tomorrow, it's on Thursdays, has been for the last several years at 3 p.m. Mountain Time. This Week in Radio Tech. We put it live on Facebook, and we put it live on YouTube. And our distribution model is we put it on as many Facebook pages as we think we can get away with. So basically, our distribution model is if you're an engineer, maybe you can't avoid us. So that's how we try to trap you into viewing. Most of the old episodes, most of the 656 episodes we've ever done are available on my website, thisweekinradiotech.com. Chris Alexander has been a guest 2 or 3 times on our show. This week, I believe it's Dave Doherty from the West Coast, and he's going to be talking about the LPFM window that's coming up. Most of the old episodes are kind of evergreen, so a lot of it's worth kind of worthwhile. If you got nothing to do for an hour and 10 minutes, and we tend to go that long, then that's what you can do. All right, let's get into today's chat. And by the way, I'm in Oxford, Mississippi, and I guess you could say I'm in a place where I'm eating my own dog food. Okay. I work for Telos Alliance, but that doesn't mean I get free stuff. We still have to pay for our stuff. In fact, we usually just buy it through one of our dealers. And I have built a radio station that I'll show you a little video clip of toward the end of this presentation. And then I'll give you a live look at the control room here and see what you think. I've been talking about this topic of virtualizing broadcast infrastructure where appropriate, where it makes sense. I've been talking about this for 7 or 8 years now. I got to look back and see when the first talk I did at NAB was, but it's been a while. And finally, for the last about 3 years, we've had some product, my employer, Telos Alliance, and there's a couple other companies as well doing some kind of similar things where we can virtualize our stuff. And now I have some real stories to tell. We have actual people working with virtualized broadcast infrastructure. So that's what I aim to show you here. All right, let's see. That's me. You know me. I don't need any more of introduction. I got 5 slides ahead, and in 5 slides, I'm going to take you through 40 years of of broadcast equipment innovations. All right, we'll take this 90-second or so journey through the last 40 years of broadcast technology, following the most familiar pieces of equipment through as electronic design tech as that's advanced. In the early 1980s, we were using analog electronics to do everything from phone hybrids to audio processors to audio consoles. But in the mid 1980s, we got the very first broadcast product containing a digital signal processor, a DSP chip. It was the Telos 10 digital phone hybrid. If anybody knows of a product for broadcast that used a DSP chip prior to the Telos 10, let me know, because that's what Steve Church always claimed, but he also caveated that by saying, as far as he knows, first product. In fact, when he experimented with a DSP chip, he said there were only 5 of these Texas Instruments chip in the US, and he got hold of one of them to experiment with. So over the next 15 or 20 years, broadcast products incorporated early digital components, and a few pieces of gear became digital through and through during that time. But a big thing happened in the early to mid 2000s, in about 2005. While equipment designers were maxing out on their purpose-designed digital gear, computer CPUs took a huge leap forward. And Ewan Roos, this is one of my colleagues, he's a senior coding developer at Telos Alliance. He explains, we've now moved from a purpose-built world to a more generic platform world. Commodity hardware and commodity software is largely able to replace their proprietary predecessors. Indeed, the most significant movement toward using PCs as purpose-built equipment replacements occurred when multi-core CPUs entered the mainstream in May of 2005. At that time, the CPU itself no longer represented a serious bottleneck in accomplishing many real-time tasks at the same time. So once multi-core CPUs became commonplace, makers of input-output, our I/O devices, ramped up their performance, increasing I/O performance, and this depended not only on faster peripheral hardware, but much faster device drivers and much faster data bus speeds. And if you've been in this business very long at all, well, like most of us have, probably 40 years or more, you're familiar with this journey through faster external devices and bus speeds. So a few short years after multi-core CPUs became commonplace and the Linux operating system was becoming widely adopted, some broadcast gear was introduced that used these two technologies to emulate what we've been doing with purpose-built equipment. So manufacturers still built equipment to purpose, but inside that equipment, we used more generic components. Again, CPUs and Linux or embedded Windows. Of course, the software applications were, and they still are, very specific to the task. So whether it's a multi-studio broadcast talk show system, broadcast audio processor, or a very powerful audio mixing console, they were built to task, like you see here, a Telos VX phone system, an Omnia 11, or a Quasar audio console. These became state of the art a few years ago. Well, now we've reached a very modern, useful, and very scalable position in broadcast technology. We're doing with specific broadcast functions what, quite frankly, broadcast automation systems have been doing for quite a few years now. We've made broadcast equipment functionality available in fully software-based systems that work perfectly in generic computing platforms. And I sometimes I talk like this is a new idea, and of course it's not. The first broadcast automation systems appeared around 1989, maybe 1988. And they were playing spots. And then when hard drives got bigger and sound cards got better, we started putting music on them. So they've been around for a long time, over 30 years. So we've been replacing cart machines and Victrolas for that long now. All right. These computing platforms are typically server-grade computers with audio over IP networking, and they're deployed either on premises or in data centers. Now, this revelation implies that broadcast equipment functionality can now enjoy the same research and development as most any other IT function. And there's a lot of that we can borrow. Today's broadcast facilities, including remote and home-based operations, can be largely virtualized. Operators still use familiar paradigms and workflows, but we don't need very much purpose-built gear, and certainly not on a large scale. All the heavy lifting by broadcast-specific audio manipulation is accomplished by generic hardware in flexible deployments. So this is what a lot of stations are beginning to look like. Here's a bold statement. IP is the most versatile tool ever adopted in broadcasting, more so than the 66 punch block, for example. And if you would have asked some of us years ago, yeah, we might have said the 66 punch block has been a very versatile and helpful tool. Either that or it's the bane of your existence, depending on how you look at it. If you don't agree with that statement, well, maybe you'll consider it true by the end of our talk here. Well, let's ask a what if question. The late Steve Church was good at this. What if broadcast equipment were actually apps on a server? What if you could install them or shut them off in a matter of minutes? What if maybe you could pay for them only when you use them? What if you could control them from anywhere, home or other offices or sports venues or live remotes? Would that be interesting and helpful? So here's a graphic that'll help us better conceptualize the evolution we've seen in the process of system virtualization. Starting with the pre-virtualization scenario on the left, this is when we just ran applications on an operating system. And we still do that, of course, today on our desktops, our laptops, and mobile devices. But it's not very efficient. It's convenient. We understand that there it is. And probably most of our automation systems still operate that way. And certainly the computer that's maybe in front of you right now does. But in the early 2000s, those multi-core CPUs made it possible to load up a physical computer with a lot more work. And thus the hypervisor was born, allowing multiple operating systems to run on the same powerful hardware. And each guest OS could be Windows or Linux or something maybe more exotic. Each OS required, though, the usual amount of care, feeding, patching, updating, upgrading, as we normally associate with operating systems. So as such, each guest OS carried its own level of baggage in a virtual machine. Now, containerized software was developed with the notion that a more lightweight environment would work just fine for each application. Only one underlying operating system is needed. That's typically going to be a Linux-based server environment. And then the container engine, typically that's going to be the Docker container engine, that engine gives each server, or each container, I should say, the attention and the resources that for it to do what it's designed to do. So the containers are largely separated from each other. The failure of one container doesn't affect the others. The container engine is good about keeping those things separate. But you only have one operating system to update and maintain in that case. Now, most of us have heard of, and a lot of us have installed and used applications that run on virtual machines, and this tech has been around for actually over 40 years, even before multi-core CPUs. But that more recent development is that containerized software, and again, often known as Docker, although there is a standard for this. It's it's OCI compliance. Containerized software doesn't need a VM to run. Software containers are executed again by that Docker engine that itself uses the resources of that single underlying operating system. Let me introduce you to Greg Shea. If you haven't met him already, he's one of my colleagues. If virtual machines and software containers both do essentially the same thing, well, what are the differences between these two topologies? And Greg is here to explain this.
Why virtual machines and containers? Why do we have both? And why would you want to use containers versus virtual machines? Well, the short answer to that is, if you've ever set up a virtual machine, you know there's a number of things you have to configure and click on and things to think about, virtual peripherals. It's rather like setting up if you bought a new computer. A container is trying to achieve the same goal, that you don't have to buy another physical computer. You want to be able to run the software independently, the installation being independent, so you don't have a conflict between other stuff that's on that computer. You want this place that's the container to run the software that you want to run. And the difference is, with containers, it is a more limited set of stuff that you have to set up. In fact, it's also designed to be automatable so that you don't have all those choices to make about all the peripherals and all those various things of setting up about a virtual machine. So a virtual machine is more comfortable if you're thinking in terms of setting up a whole computer and a whole environment for a piece of software. But a container is a very strategically designed piece of a virtual environment that allows you to run the software that you want to run with a minimum of other stuff, a minimum of overhead to worry about. So it's kind of more of a contained package, thus container.
Well, containerized software actually looks to be the future of computing services. So microservices in containers are the industry future trend for software. It's used by large organizations like Google, Amazon, Visa, PayPal, MetLife. I mean, if you sent me $10 using PayPal, well, first of all, I'd appreciate it. But second of all, you would be using containers to make that transaction happen. Last summer, I was playing putt-putt golf with my son and my then girlfriend, now wife, Carmen. And there was a foursome right behind us, and the gentleman in the foursome, I struck up a conversation with him, and turns out he was an IT data center manager. And I asked him, I said, you guys using containerized software, Docker containers? He said, that's all we have. Everything. I mean, my desktop isn't containerized, but yeah, all the servers in the data center, they're all running Docker container software. I think it was a healthcare organization, but they certainly had moved to that. Well, we're learning a new technical concept here, and one that may take some thought to really wrap your head around. We asked Jake Alderman, another colleague of mine, to take a stab at answering the key question, what is containerized software? And he nails it pretty well with this answer.
Containerized software is a new method for deploying software in a more lightweight manner. So traditionally, we had applications that installed onto an operating system and would run on your desktop computer or a server. And we're all used to those in the broadcast environment now. And in the last 10 years or so, we've started to see some people use virtual machines, and that's taking a physical piece of hardware and making a virtual version of the computer, installing the operating system, and then installing the application on top of that operating system. Containers are a middle ground between those two. What we're able to do is, instead of virtualizing the whole machine, we're able to create an isolated place to just install the software we need, like an audio console or a phone system. And so what we do instead is we share the operating system, but we have this isolated bucket so our audio console doesn't touch anything else. And it's not actually called a bucket, it's called a container. So you've got your container that holds your one application in isolation, similar to a VM or a physical computer, but it's able to share the resources of that greater compute platform.
Well, visually, graphically, here's how containerized software fits within a compute platform. So underlying everything is some bare metal hardware. Now, this could be a virtual machine. In other words, the host operating system that's shown right above the server there, that could be a VM on a larger machine. But for now, let's keep it simple because this is the easiest way to deal with it. So you have a bare metal machine, the host operating system, which is going to be some flavor of Linux. And then you're going to have the server will be have multiple CPU cores, dozens of gigabytes of RAM, enough disk drive space to hold the OS and the containers. And by the way, in the audio and telephony world and audio processor world, we're not writing big files. There may be a log file, but you don't need a lot of disk space. You're going to have extra cooling fans because it's a server, so you're going to have the benefit of that servers give you dual power supplies, plenty of, like I said, plenty of CPU cores and all those fans that are in there. Within Linux, we're going to install that container runtime engine like the Docker engine, and this will then service and support the broadcast applications that we install in containers. These will be containerized audio consoles, as Jake mentioned, phone systems, intercom systems. We now have an audio processor, the new Forza processor from from Omnia that's available now. Well, let's take a quick review of an audio over IP network, and this pretty well holds true no matter which brand that you have. So it begins with this network and a core Ethernet switch. To that, we're going to add some input-output devices. In the Axia world, these are X nodes, and they can be AES-EBU or analog audio or mic audio. And then we have some interesting new offerings that offer MIDI audio in and out, audio over SDI video. There's a number of options now. We can also, bring a computer into the situation where instead of a sound card in the computer, we just put an IP audio driver and an extra network interface card and tie that into the network. And then when we have our sources and destinations on the network, then we can add an audio console. And typically, there'll be an audio mixing engine that's in the lower left, the silver thing. And then there'll be a console that you can kind of think of it as a glorified mouse that happens to look like an audio console. So there's typically no real audio in the surface itself. It's just telling the mix engine what to do. Hey, subscribe to this mic and that mic and this automation output and this codec output. Mix them together at these levels, and then of course it makes new streams like program 1, program 2, control room headphones, mix minus feeds, things like that. Okay. Now, once we have all that working, we can really easily add, say, another console. So instead of your facility being console-centric, it becomes network-centric. So here we add a console. This happens to be an IQX that has the mixing engine built into it. So literally one cable, and you have access to all the sources that are already on the network. And then you can add a local source like the microphone or, add some speakers and things like that through an Xnode interface. All right, what if we replaced that surface with some software, and the software told the mix engine what to do, mix at these various levels and so forth? Well, there's the first one that came on screen is Soft Surface from Telos Alliance. The next one that popped up there, that is a third party. That's IP Studio from a dealer in France, and he writes software that's very flexible and customizable for mostly for his French clients, but it's available worldwide. And then there's other things like the Telos Alliance Pathfinder software that you can make little functional consoles or routing buttons and things like that, and that can tell different devices what to do. Well, here's a new idea though. That's this. And the rest of the network stayed pretty much the same, but you see in the lower left, we have that familiar picture that we saw a few minutes ago, a bare metal server with the host operating system and the Docker engine. And on top of that, I've written Altus. I've put in there 6 Altus mix engines. And that's essentially the very same software that runs in a hardware engine from Telos Alliance, but these are all each running in their own Docker container. How are they controlled? Well, they're controlled. Each one of those Altuses has a web server, and so you can go anywhere and just simply browse to the IP address, enter your credentials, and you have an audio console in front of you in a browser. And since it's in a browser, it means you don't have to install anything on your device. And it can be an iPad or a Chromebook. I've used Chromebooks to do this. You can buy a Chromebook for $250 that's got a touch screen on it and works just fine. It's plenty fast. In fact, the device doesn't have to be all that fast. It just has to run a web browser, pretty adequately. That means also you can be across the internet, and you're not running LiveWire or AOIP across that connection. If you do want to have audio to and from there, we have an option for WebRTC, which actually is how you're hearing me right now, using WebRTC or something similar that Zoom has developed, but the standard is WebRTC. And so that can be any number of bit rates using the Opus codec. All right, so that's how other devices can control Altus consoles. So you can do audio mixing without having a physical surface. Any HTML5 browser will work, and they all have been since, I think, 2018. You can have a temporary studio anywhere, distributed workforce. Home studios don't need a purpose-built mixer. They're using the mixer that's back at the station. You can have small studios, desks, even mobile studios, and actually you can have multiple simultaneous users. I think you can have up to 10 people browsing in to the same console at the same time. And if one of them moves a fader up and down, well, they all see it move up and down, and it really happens instantly. I mean, you don't even see any delay between these things. So let me give you a few examples. This is one of my radio stations in Greenville, Mississippi. This is Big V. We scared him to death. Normally he does his hip hop show on that big console. I just briefly installed an IQS console. Actually, this is the predecessor to the Altus, and showed him, hey, you can run 2 shows at once. He didn't like that idea, but he thought it was kind of cool anyway. But if you have, holiday events or sports, things like that, easy to add more mixing control. You have a legacy console. So in this control room, you can barely see it to the right of the guy's head there. I have an Axia Element console, and it's pretty long in the tooth. It's probably 15 years old now. And someday, it's gonna fail and won't be worth fixing. So we're just going to replace it with Altus, and any touchscreen will do. It doesn't even have to be a touchscreen, but literally a $200 computer and a $300 Dell touchscreen, and you have a very nice audio console surface. It's also a pretty small footprint. And at the end of the talk here, I'll turn the camera around and show you what's in the room that I'm in right now. You can also do mixing from the desk that you normally occupy. It doesn't have to be in a control room. So this is Chris Green. That's his normal desk computer. He's touching it because he wishes he had a touch screen, but he doesn't. So you could just use the mouse to run the controls there. Or, like I said, for $330 or so, you can get a Dell touchscreen. So that's pretty cool. How does Altus fit into some on-premises infrastructure? Well, so here we've deployed a PC server with Ubuntu Linux, the Docker software. I'm showing off the Wi-Fi and the internet as possible connection media. We know that Livewire and AES67 audio over IP don't go over those connections. So that's why you could use the WebRTC functionality to contribute or to monitor, or both, from locations that are not on the LAN. If you're on the same LAN, like the laptop in the upper middle, then yeah, you could have the IP driver running on that laptop and get your audio in and out that way if you needed to hear or contribute. All right, so what are some other things you can do? Well, here's a phone system. This is based on the Telos VX, and there's over 2,000 Telos VX phone systems now deployed around the world. At big and small stations and networks, and ESPN and C-SPAN and ABC World News Tonight and so forth. But when you buy a phone system from Telos, you got to make a commitment. In other words, it's not granularly small. It's going to maybe have more capability than you need. Well, with a software-based system, you can actually license in the number of incoming lines you want, and you can license the number of hybrids you want on a granular basis, and you can add to that just by paying your dealer more money and getting more licenses. I've just installed one of these here in Oxford, Mississippi, and we're just finally getting the 10-digit number applied to it, but it works internally just fine. And this kind of thing is available on a buyout or a subscription basis. And you know what? That investment can last longer than the hardware. If the hardware dies, if that server dies, servers are pretty generic. So let's say your Dell server dies and you got a deal on an HP server. Okay, fine. Install Linux on it and away you go. The software doesn't care. So as long as it's got fast enough CPU cores and some RAM. Another possibility is this. This is the Telos Infinity VIP system. So it's an intercom system, but instead of being hardware based, you can actually have the VIP software installed on a server, and then you can use remote devices like phones or tablets or laptop computers or desktops. And guess what? It's still compatible with the hardware panels that Infinity VIP started with. As long as they're on the same network, that can work fine. Actually, they can even be remote using a codec, multi-channel codec link. They can be remote, and this is really quick to deploy. So, for example, if you're in the TV biz and you choose to use Grass Valley's AMP system for distributed television production, live production. If you pay them a little extra money, you can get an intercom system, and when you do, it'll be this system. I know that, for example, for the Queen's funeral and for the King's coronation in England, VIP was used because it was quick to deploy to all the cameras and all the people that needed to be on the intercom system. It's great for sports. Formula One racing is another user. of this system, because they can quickly deploy it out there. So there's 3 examples of console, phone system, intercom, and I need to add to the slide. My goodness, I need to add our new audio processor called Forza. Right now, that processor is not doesn't have FM processing built into it. It's appropriate for stream, HD, DAB processing. I just heard it today on a stream, and it sounds wonderful. But and FM's coming. It's just not ready yet. All right, so how do you deploy this stuff? I've shown you deploying it on your own hardware, and plenty of people are comfortable with that, but also plenty of people are not comfortable with that. Well, there's a couple other methods. One I'll show you here, and this is from Broadcast Bionics, outfit out of England. And they have a product called Virtual Rack. It comes in a couple different sizes. And Virtual Rack is set up to do all the hard stuff under the hood for you. You don't have to worry about command line anything. You basically turn the server on, hook up a mouse, keyboard, and monitor to it, and you are presented with kind of the equivalent of an app store. You choose the functionalities that you want, and it's not just from Telos Alliance. There's a couple other manufacturers making broadcast appliances that run in containers now as well. And you click on the things you want. Virtual Rack literally installs them in under a minute typically. And now they're not licensed. You still need to contact the manufacturer of the container functionality that you want, whether it's a Telos console or a Forza audio processor, or I want to say Diva may be making something that's in there, and Orban either is or will be. So you need to license those things from the respective manufacturer, but Virtual Rack is a really convenient way to deploy this. All right, let's look a little bit closer at this audio console. Here's the Axia Altus. It can be up to 24 faders. There's 10 shown on that particular screen. They kind of resize automatically, and if you have more faders than your screen shows, then there's there's in that screen there's a blue bar over toward the right-hand side where it says line 1, line 2, line 3. Just barely to the right of that little blue bar, you click on that and you see more faders. It really works well for with a mouse or by touching the screen if you have a touch screen. It does handle multi-touch just fine, so you can touch several things at once. And I've been playing with it here at this station where we're about to go on the air on Monday. Well, we're on the air now, but we're about to go live on Monday. So just a reminder of how the stuff deploys. It's delivered as software, represented there in the command line box. You put it onto a server-grade computer on premises, and that's what most people are doing right now. Some of the really big broadcasters, especially in here in the U.S., but also in Europe, have deployed this into data centers, including Amazon Web Services, and then you control it using any browser. Again, cloud or on premise. So let's now hear these stories. I know I promised that early in the talk. So we have some radio stations in Portland, Oregon that, just like, seems like half the other people in Portland, the radio stations became homeless for about 7 months. They literally had no place to set a console down. So they put this to use, and we'll hear the story from the engineer, Jeff McGinley. These two guys, they did a morning show together for years, and then one of them had to move far away. And he was the one that ran the board. That's the guy on the right. We'll hear their story in a minute. This guy, Thane Conrock, he's from Oklahoma. He's an IT guy, but he loves radio. So he and his partner bought a radio station, and they have some nice things to say about containerized software. And then this guy, Chris Green, you already met him in a previous slide. He's the morning man at the station that I'm at right now. In fact, that picture was taken yesterday in this control room. All right, so let's hear from Jeff McGinley. I connected with Jeff on a video chat, and I let Jeff tell us about his radio stations in Portland, Oregon. They got into a real pickle regarding their studio space, having to move to a new location, and that new space, their new place, was not ready for the move-in. In other words, they were homeless.
We're here to talk about a technical solution that you and Telos Alliance worked out. I think no person better to tell the story than you. So tell us what the problem was and tell us how you solved it.
So we are moving. We decided to move out of a studio facility that we were in for 25 years. The infrastructure was old and the building was kind of falling apart. And so we found a new facility that we were going to move into. The problem is that we ran out of time to build the new facility before we had to be out and demoed of the old facility. And so it became a very quick 6-week crush to figure out how we were going to keep our 7 radio stations on the air here in Portland without really, built professional studios. And I reached out to Brian Jones, and he came by, and we had a very good talk about this. And I ended up handing him one of our new servers, and he came back with the VMs and the stacks all built for Altus. And we've been using that now for about 2 months to keep all of our stations on the air.
By the way, we recorded that interview while they were homeless. They are homeless no more. They have moved in to a new gorgeous facility. They've got all Axia consoles everywhere, the Quasar consoles, but they kept 2 of the Altus consoles online, ready to go, so they can go do remote things when they need to, and if they have to, for some reason, bug out. So, Jeff, if I understand correctly, you've placed your station's automations and phone systems and several mixing consoles at a central location with easy and yet secure remote access, right?
It's a central location for all these various places around Portland that we have to broadcast from. We've got full control over that. Everyone can reach into it using a VPN. And so up there we have all of our main automation system, our ability to import media into the automation system, our main file server, the loggers, everything is up there and can be accessed remotely. Including the Altus server that can actually be controlled remotely as well. It's up there in the central location.
So here's a schematic diagram. The central location that he referred to is actually a transmitter site. Turns out that 5 of their 7 stations are FMs, and they're all co-located at this transmitter site. It's in a great strategic location in Portland. It has plenty of backup power. It has several sources of internet going to that site, and they don't own the site. They rented more space to put a couple of server racks in to make all this happen. So at the transmitter site, they have the Alta systems, they have their playout systems, and then remotely they did some sports talk shows. Well, it's not practical for several people in the same room to be on microphones that individually go over the internet to the Altus console, because you've got some delay there. So you need to mix, if there's people in the same room, you need to mix them together locally with 0 delay, like on an analog console or an Axia console, like I'm doing here at this station, and then send that mix up through the WebRTC channel back to the Altus console. So at the studio, at their temporary office locations, they had several around town. They did put a little Mackie mixer in there to mix the local people together. Of course, they heard a mix minus coming from the Altus, so they could hear the commercials and anything else, the bumpers and network news and sports and all that kind of stuff. And then they had another computer that they used to access their Enco playout control. All right, what about remote access security? Security should be on every engineer's mind here. Jeff says that while remote access security requires proper setup, it is easy for authorized users to remote in and do their jobs.
We have a VPN client that we use that we enable, and then we log into, and it does 2-factor authentication, and it connects all of the. So for the end user, it's very simple. All of the magic happens inside the firewalls to allow, in the group policies, to make sure that user has access to what it needs to, and that the firewalls are open and allowing all the traffic through that needs to. So for the end user, it's simple. It's really easy. For the networking team, the firewall team, for us, just to make sure, it's a little bit more complicated, but once it's up and running, it just runs. It just runs. We don't have to screw with it at all.
Well, now here's a couple other guys, Jeff Kingman and Jeremy West. They've been doing radio together since their college days. And since 2006, they've created a hugely popular morning show on KZOZ FM in San Luis Obispo, California. However, in early 2022, the longtime friends had to plan their breakup. And Jeff picks up the story.
But what happened is Jeremy's wife got an awesome job offer in an area with a significantly lower cost of living that Jeremy just happens to like to live in. And we were going to either end the show or continue on. And that's where your guys' technologies fit in.
Yeah, so I talked to one of your engineers, and I told him what we wanted to do. And he said, well, I'm actually working on a project because of COVID where we could actually, control the studio from your house. It'll be a monitor, touch screen. And I said, well, that's exactly what we're looking for, because over the course of the 20 years Jeff and I have been working together, I run the board. And I wanted to make it as easy as possible to transition. So I was thinking, if I could control the studio just like I normally do, and Jeff could just show up and talk into a mic like he normally does, that would be the easiest.
So I got a call for like 10 minutes.
So now we're Jeff's still in the studio, so they're getting ready to do a contest. But so that's kind of what happened. So when Milos came up with this design and this product, I was like, yeah, we'll be your test dummies on this. And it's worked better than the console that we had in the studio, which I have to say is an antique and a relic from 2000-ish. So this thing does a lot more. It's easy to use. I bought a simple touchscreen monitor, and I control the studio from my house in Washington State.
So Jeremy's really jazzed about his Altus console. In fact, we asked him if the Altus was nicer than the console that he'd been using for 17 years. I think he just said yes.
Yeah, I got to tell you, it's a nicer console that I've been using for 17 years. You know,
go.
a lot of times in radio, if it's not broken, you're not going to replace it. So we've been using, a console from 2001, and it was a great console back in the day, and it still works. And that console is still in the studio because, there's a few of the older DJs that prefer to use that over the touchscreen. The touchscreen goes right above it. Our engineers have wired this up so you can either go digital or analog. But it's an amazing console. I love it. I love the flexibility of it. It's made my job way more easier to accomplish every day. And I'm thankful that they came out with it. I remember talking to some of the engineers at Telos back when they were in the design phase of this, before they even had the actual prototype and what it would be able to do. And this thing has blown away my expectations of what we originally talked about. So I highly recommend it to anybody who wants to work from home.
And when Jeremy's talking about his console, it's the best picture I could get of it. This is what's on his kitchen table. So this is what he's looking at when they're doing their show. He's got the browser window for the console squeezed down kind of low, and that actually forces it to have more faders visible on the screen because they need to keep the same height to width ratio. And then there are two more windows toward the top there. One of them's got the green VU meters, and those are his contribution channel and his monitor. He's running two monitors at the same time on there. So anyway, that's what he's looking at on just an ordinary computer literally just running a browser. All right, this is Thane Conrock. He's a partner in Werewolf 97.5 KZLF. It's a 50 kilowatt FM station in Alva, Oklahoma. Small town radio for sure, but Thane and his partner are keeping their costs low while making a really solid impact in Alva and their surrounding counties. One way they've kept expenses low and the flexibility high is by using containerized software for their audio console and their phone system.
We do all of the studio work virtually as well through the use of newer products in the containerized world, where our mixer, our console is virtualized, as well as our phone system is virtualized, and we have nothing but microphones and touchscreens in the studio. It's pretty slick.
So here's the main studio that Thane mentioned. It's simple, it's elegant, it's completely effective. This same control and mixing is available literally anywhere in the world. So one of the screens there is on their automation system, and the other one is on their IQS console, similar to the Altus console we've been talking about. And what you see there is pretty similar to the room I'm sitting in right now at WBZK here in Oxford, Mississippi. Thane is enthused about the benefits that a station is getting from virtualized broadcast infrastructure, and continuing here, Thane shares his thoughts about the Axia virtual mixing console.
fantastic product. It's something we had wished when we had previous station used the IQ product in a physical form. This gives you the same functionality, but it's literally a virtual touchscreen and just that easy. It can be pulled up anywhere. So we have a touchscreen in the studio that has nothing but that on it, and the other touchscreen has our playout system also virtualized. We just basically have a essentially a VNC or a remote terminal into that playout system. So everything, if the studio were to crash and burn, lose power, we'd lose the mics, of course, but the station would still be fully on the air because all the guts, the software to produce the content and the software to mix the content is all virtualized in containers. It's really a wonderful system. The VXS, which is our phone system, is also a product that has transformed the way we take calls. We have a voice over IP system that has a PBX and a SIP trunk coming in from a provider that ingests that natively. So our call quality is incredible.
Too often we consider the latest technology as being only available to large broadcasters with big capital budgets, and certainly it is. Thane says, though, that's not the case with virtualized infrastructure like Axia Altus and the Telos VX.
For us and for many stations, especially the smaller operators, they will have the ability to get into some pretty amazing features, technology, and audio quality for a very, very low amount of money comparatively to if you look at conventional physical studio equipment that costs an enormous amount of money, thousands and thousands and thousands of dollars, that now you can have in a virtualized or in an IT-based format for significantly less money, but have that big city, that big station sound that everybody wants.
So most of us older on-air talent are used to real tangible faders and even rotary pots to mix our shows. However, Altus is typically used with a touchscreen, a flat touchscreen. So how do you approach your more seasoned talent, Jeff, how did you approach them with news of their new operating surface?
I had some deep reservations about a few of my people that have been around and have used a lot of more analog technology, and I was pretty anxious to have them start using it. And those people have been the most reliable and have needed the least amount of hand-holding and troubleshooting. They've really gotten to a point of just clicking and dragging a fader with a mouse or turning on and off the source. They picked it up within the first air shift, no problem.
Wow, and I didn't expect that, but I'm glad I asked him. So again, here's some pictures of different systems. I'm right now sitting in the room where Chris Green is in the lower right-hand corner there, and I'll turn the camera around before we get done. So here was my modern day scenario. Now we've gone ahead and built the station now, and it's been on the air for a couple of weeks. We just got the HD 1, 2, and 3 working yesterday. The station is mostly automated. Live local morning show. We have no line of sight between the studio and the transmitter, but we have excellent fiber internet at both locations. What's kind of sad is that, well, it's not sad, it's just the way things are. At the studio here, we're in a business park, and it's all one-story buildings, mostly attorney offices and some medical offices, and the radio station. You're not allowed to put anything on the roof, nothing. And the tower that holds our antenna, if I were 12 feet up, I could probably see it. It's only 2.5 miles away, but we don't have line of sight, and we can't put anything up to shoot over there. So we had some choices, and I want you to see what the choices are or were, and then you can see what we decided to do. Traditional setup where we would have all of our computers at the studio. We happen to use Playout 1 for our automation. So the Playout 1 server, the FM Playout, the HD2 Playout, the HD3 Playout, they're all separate programs. Stream processing, an ingest computer, the Nautel multicast importer exporter, and then we were going to use the Axia Altus no matter what, so that's on a computer along with the Telos VXS phone system and a spare computer. Then we'd have a couple of nodes and a Sage, and then we'd use public internet to move all that stuff, all that audio over to the transmitter side, and we would use micro MPX algorithm to get the FM analog over there, and then the Nautel multicast would move the HDs over a bit stream as well. Okay, so that was scenario number one. Scenario number two, it's a long story, but I needed two different scenarios to show to the other owners here. So I looked at putting some of the gear at the transmitter site. Okay, the multicast importer exporter particularly, and using a standard codec from Telos to move the audio over there. But then I thought, you know what? Why not take a cue from Thane Conrock and from Jeff McGinley and actually put everything at the transmitter site and then just remote control it? Could we do this? Well, I'll tell you, one of our other stations in Mississippi, we do have everything at the transmitter side, but we don't do any local live show on it. It's all voice tracked all the time. We don't have a morning. We don't have a local morning show. We do Murphy, Sam, and Jody out of Louisiana, which is a great show, by the way. So I thought about, let's just put everything there at the transmitter site, including the EAS. We loop through a Sage EAS and some external relays, and then we just remote control it from the studio. Well, that's what we did. And so just this next video I shot just yesterday with Chris Green. If you know, we're here in Oxford, Mississippi with Ole Miss University. And if you know Ole Miss, you'll see that Chris here is feeling hotty-toddy about his new control room.
Yeah, that is way too cool. This audio console is probably the greatest one I've ever used because it's here. Yes, I know it looks like it's here, but it's not. It's at the transmitter site, quite literally. I don't even have to think about what's going on. A lot of moving bells and whistles behind the scenes, but I can touch it. I can literally move levels with ease. It's so seamless for me, and it's helped us at 94.7 The Buzz in a big way because it's one of those situations where I don't know how they do it. Okay, I don't care how they do it, but everything I need to do, they're able to provide it in a seamless, great kind of way that works for us.
So Chris is not real technical, but he sure is excited. He's been using the board here for a while. So here's the virtualized operation. The left-hand picture is the control room. I did have to provide them with some, production capabilities. So there's a prod computer, and at the moment, I've got our older virtualized console, the IQS, mixing things here locally for doing production. We actually may end up, we may keep it. We may end up going with a little analog console. The screen that's got the automation meters on it, the second one from the left, that is just a remote view into the Playout 1 computer at the transmitter site. And we can also pop up a little router box there to route, hey, is the automation on the air directly, or do we put the console on the air? But that console, that's just a browser window that's maximized. Same thing for the automation. That's literally a browser window that's just up and maximized. On the right-hand picture, that's me at the transmitter site. There you can see the Nautel 2.5 kilowatt transmitter. On the left, you can see the Omnia 11 processor that's doing the FM and HD1. I'm actually using software processors from Omnia for the HD2 and 3. Those are in some Dell servers that are below the Nautel transmitters. And then the white box at the bottom left, that's the Ethernet switch for the audio over IP network. Down the right-hand side, there's our EAS gear, and then there's the automation systems for the FM and the HD2 and HD3, and then the automation server below that. So when we get the screen on the far left with the console, that is simply done by remote browsing into the container that's in one of the computers on the left-hand side, on the left-hand rack. Okay. So how do you feel about this statement now? IP is the most versatile tool ever adopted in broadcasting. I'm really amazed at IT people who have great skills in here. I've had to learn just enough skills to make all this work, and it's been very gratifying so far. Let's see. I got a couple of tips for you. I'll leave you with that you may want to make note of. A lot of people use TeamViewer or Splashtop, and there's there's other remote access. There's just regular RDP. I found a literally free service that you're welcome to donate to, and I do donate to them. It's called dwservice.net, and they have the little client, which they call the agent software. They make it for Windows, for Mac, for Linux, and a couple other things too. You install that on the computer that you want to control. It's quick and easy to install. Literally I can do it in under a minute these days. And then to gain remote access, you literally just use a browser. You don't have to install, TeamViewer on your own computer that you want to do the access from. You just use a browser. You can group your computers. I've got probably 60 computers I look after now, and they're grouped by our station groups in different cities. You can also create temporary remote logins. So like I had to give remote access to one of our tech support guys at Telos. And I just made him a link. It's a long link with a blob of security attached on the end of it, and then it still has a password. And he had, I made up the password. He put it in, so it only works for him. And you can time limit that. You can only make it work, for an hour or a day or whatever you want. There's another thing that you might want to be aware of. Of course, FreePBX is a terrific free voice over IP SIP PBX system. So if you want to save money on your phone bill, that's a great solution. I actually interviewed the creator of FreePBX. Now he used open source tools like Asterisk to make it, but FreePBX he then sold it off to a company. But I interviewed him recently on This Week in Radio Tech. Just a super individual. There's a new technology called Secure Tunnel. And this may be a great way for people of ordinary skills like me to not have to install VPNs. And it gives you very secure remote access only to the things that you are allowed to access remotely. Cloudflare is offering secure tunnel service for free up to a certain number of people. And I've been using that to access some of my gear back at my house. I could do it actually with DW service, but I wanted to play with Secure Tunnel. Love it. Hey, if you're new to IP radios, let me suggest that you play with those and learn about those. I wrote an article about how to make IP radios from Ubiquity work for audio over IP, like Axia Livewire. And if you're curious, contact me. I'll send you a link to that article. And finally, this is the end of the show here. If you want to learn more about software containers, Telos, I did through Telos about a 7 or 8 part series. I mean, you learn more than you ever wanted to know about software containers, but it's all broadcast applicable. So it's not generically talking about software containers. We actually apply everything to broadcast. And if you hit that QR code right there, that'll take you to a landing page at Telos Alliance, and you can watch any one of them. They're all titled and labeled. So if there's a topic you're interested in, you could just go watch that webinar about software containers. And that, my friends, is it. Stop sharing and get back with you. Is everybody still awake after that? I usually don't get any questions because I've baffled everybody or put them to sleep. I'm not sure which. I promised I'd show you the room here. So, okay, so I'm at WBZK. I think that's our call letter. It's the buzz. I guess it's BZK. So I'm in the control room that you already saw a couple times. Make sure I'm not pulling any wires out here. Okay, so here is, this is a touch screen. There's a little tiny NUC style computer back behind there. We found a $220 computer that has 2 network ports on it. So that's great because it does live wire as well to get audio in and out of it conveniently. I'm going to hit F11, and now we're back to just a browser window. So you can see it's just a browser window. I can move it around, or I can maximize it, and then I can absolutely full screen it, and we're back to having a console full screen. This console's not on the air right now. I've got the automation routed directly to the transmitter, but I can change that easily too. So I can turn, turn the mic on, and the mic is actually a codec. So that's WebRTC built into Altus, so that remote on my remote browser, which actually is this browser, I will get WebRTC, and I will have my audio connectivity to and from the console, to and from this fader right here. If I had it connected, you'd see my audio levels popping up there, and then I can hear the mix minus that's coming back from there. And of course, the console doesn't have to be up on screen in order to keep running. I told you that this isn't on right now, even though the meters are moving, because I've got it. I'm not routing through the console right now, but I can actually just kill this browser. Now this is the actual wallpaper of the actual computer that's here. But even if we were on the air, we wouldn't, through there, we wouldn't have gone off the air. So I'll just reopen the browser. I made a shortcut right here that the jock can just click on the shortcut, and he has to enter a username of Surface and a password, and it has to synchronize the console state, and boom, there it is. Hit F11 and they're full screen again on the console. The automation system is over here. It is a touch screen. It is live. And this is actually DW service. So this is like, TeamViewer or other remote desktop, because the Altus console has a web server built into it. So I just go browse to it. But the automation doesn't have a web server built into it. So I have to go actually to that computer, but I make that full screen over here. I can F11. This is DW service just in a browser, and I can F11. And of course I can close that browser and we stay on the air. It's just a look at that computer. So, whew. Sarah, did I have any questions after all that?
So that's an audio editor behind you. Is it an Odyssey or?
Yeah, that's
Adobe.
That's what everybody uses. Adobe version 3, which may or may not be cracked. I don't know. I didn't install it.
Yeah, there is one business question I would ask though. When you sell that much software, I presume it's an ongoing monthly license kind of thing, and maybe use-based and all that. How does that work with you? You get one bill and it's itemized by how many hours of this, that, or the other thing?
So good question. And at the moment, we Telos doesn't. We don't have parking meters. We don't have that business functionality very well done yet. So right now, all of our software products are available either for buyout or subscription. And there's a slide earlier on where I said you can pay for it only when you use it. Well, okay, not very granularly. You can I think at the moment probably 1 year is the minimum. You can subscribe to it or buy it out. If you subscribe, then subscription, I want to say, costs about roughly a fourth of what the buyout is. So after 4 years, you would have paid for the buyout. If you buy it out, we still encourage you, if you want, it's not required, to have a service level agreement. Some of our products, I think, actually do have a required first year service level agreement, because most products, the difficulty comes in the original installation, and you may have questions and problems, early on. But we don't have any way to charge by the minute yet. So that's really not quite accurate. But you can subscribe to it for a year. Yeah, I hope that answers your question.
Thank you.
All right. Hey, where are you guys joining me from? What facility is that?
This is Crawford Broadcasting. It's the building we're in. We're in the conference room downstairs.
Oh, nice. Okay.
Right next to the H Mart, in case you like Asian dining food.
Well, I wish we had built a radio station in Oxford, Mississippi years ago. This is a very delightful little town. being a university town, it does have a critical mass of smart people, unlike a great deal of the rest of Mississippi. So I'm delighted that we've built a station here finally. It's a lot like Franklin, Tennessee, a suburb of Nashville. If you've ever been there, it's a really nice town. I know you've got nice towns there. You got a lot of smart folks in the Denver area as well. But this has been delightful to build this here. All right. Well, Amanda, thank you for inviting me. I sure appreciate it. This has been a science experiment for so long, and now it's actually happening at several stations, and mine as well. So I just hope Chris Green, our morning guy, can be comfortable with it too. He's more of a buttons and knobs guy.
Well, thank you so much, Kirk. We appreciate you joining us.
Thank you, Kurt.
All right. Thank you all. Take care. Bye-bye.